It was developed by some researchers who were, using at that time the S language. S was then also more wasn't as accessible to everyone. So they went out and started to develop something called R, and which has now become a very, very popular language. So here's just a sort of graphic coming from RedMonk, which is one of the tech web pages that you use. And what it's showing you is popularity in terms of on GitHub, in terms of projects. So you can see it has over, hundreds of projects. And you can see also in terms of Stack Overflow, which is where a lot of the forum for sort of technology support is required. So you can see it's very popular. It ranks quite high up there, and it's very popular. So when you compare R to some other statistical softwares, the thing is that one, it's not proprietary like SPSS or SAS, where you require a license. So it's very versatile and it's highly customizable. And so because it's open source, you can take the code and you can customize things for your own purpose. And then users can also write their own functions. You can develop a package, you can make that available, and you basically become a contributor to the global community, fostering a collaborative and ever-evolving platform. So it moves very fast. You'll see the updates come. One of the downsides of R is that, compared to other sort of more GUI-based, and by GUI we mean graphical user interface-based, it has a bit of a steep learning curve. And so, a one-day workshop like this is not going to make you an expert at R. What we're trying to do is just expose you to how to get started in using R, for those of you that have not been exposed to it. For those of you who have, there's always something to learn, because always to share exactly step by step how you did that analysis. Unless, of course, you were, programming in Visual Basic, or you could write some macros in Excel or something like that. It's very difficult to show step by step exactly what you did. Whereas with something like R, this is the beauty of it, is that you can make that code reusable. So, in a few days, you get another data set or another batch of data. You can easily go and run your script just by reading in the new set of data that you have. So even though the learning curve is hard, is a bit more steeper, what we say is that because of the power of its flexibility and this whole scripting environment, that it's very efficient to use once you've obviously got your workflow in place. In terms of integration and compatibility with other...
This meeting is being recorded.
For example, climate data or grid data based on different, for example, soil parameters, if you were interested in that, or even large genomics data sets. Depending on what your interest is, you can have R connect to a whole host of different diverse data sets. So as we mentioned, the interoperability with different languages and also different database programs is particularly beneficial. And then you can draw it from various digital platforms and also in different formats, whether it's in Excel or flat files or database formats. You're able to connect and retrieve and integrate with different data sources. So that's a little bit about what R is. If some of you have used R, integrated development environment, that's just technically for, if you would like to think of it in the analogy of a car, R is basically your engine.
This meeting is being recorded.
So basically, R is what is doing all the heavy lifting. It's doing all the,
This meeting is being recorded.
Editor, and then you can directly execute editor, And then you can directly execute your code in the R engine, okay? And you can also have tools in place for example, for looking at plots, where you want to see some visuals of whether it's maps or pie charts or different types of graphs. You'll be able to see that. You'll be able to see some history. So what are the commands you already ran? What are the objects, data objects that are stored in the memory of R? And then you'll also be able to do some debugging. For example, look for parameters or look for flags for different functions that you are doing. And you can manage your whole workspace. So that's the beauty of RStudio. And that's what it allows you to do. So in terms of when you're getting started, so this is for first-time users who have, had no or little exposure to R. What you will first do is you will go and get R. So depending on whether you are running it on a Windows or a Unix or a Mac system, you would go to that specific. I've put all the links over here. You should be able to then connect to these links. I will share the presentation with Dr. Barhanu, and he'll be able to send it to the whole mailing list. So you will have these links at your... so these links are for downloading RStudio. Sorry, I should mention that. RStudio has now changed to a company called Posit, so some of these links may have been updated. But, if you Google Posit or RStudio, you should be able to get the links quite easily. After you've downloaded RStudio, you can then go in and also go to the CRAN repository and download.
Being recorded.
So what does the R interface look like?
Being recorded.
So what does the R interface look like? Instead of going to the actual R interface, I'll be showing you what the RStudio interface looks like. So you will see a window like this, generally when you first time you start up. And what you will have is these 4 quadrants, okay? We call these different window panes. And these are all resizable. So, your quadrant 1 may not have been fully open, so you may not see it. But these are all resizable windows that you're able to see. And quadrant 1 here, what you will normally do is you will write your script over there, and you will be able to visualize your data. So, whether it's coming in from Excel, whether you're reading it from a file or a
recorded.
Okay. So you tell it, for example, 3 plus 3, and that will be a command for it to say, okay, it's an addition. So the answer to that will be 6. So until you see that console, that means that it's still processing. Until you see the command prompt, that means that R is still processing the command that you provided to it. Q3 here is what we call the environment. And by the environment here, we mean, what are the things that R is already storing for you in terms of, for example, functions or what we call objects. So if there's data that you've read into R, the R system recognizes that as an object. And I will cover a little bit on that, on what an object is as we go along. And then quarter 4 is where you're able to see things like all your files. So you'll be able to browse different files based on what your working directory or what your working environment is. So you'll be able to see that in quarter 4. You'll also be able to see plots. So you see that there are different tabs up here. I'll get you a more zoomed in view of this. You're able to see what are the files, what are the plots, and what are the packages. And you're also able to get help about these different functions in R. So this is more zoomed in view. You can see, so as we said,
the recording has stopped. Recorded.
Objects in your global environment. And then here, as we mentioned, you can see what your files are, different plots, packages, help. And there's also a viewer if you were using some other packages. So this is what RStudio looks like as when you start with. And then as I mentioned, R defaults to what we call an interactive mode in Q2. So if you look at this quadrant 2 here, you're able
The recording has stopped.
You're able to see this greater than sign. And that's basically saying, okay, I'm ready to accept the next
This meeting is
command.
being recorded.
So here you can see some simple commands that you can give R. For example, you're able to do, so when you provided a command, in this case, we've put a hash in simple arithmetic. Whenever you have this hash symbol, that means it ignores that command. It just takes it, like, for example, if you're writing some notes or some comments, you're able to precede that with this hash. So here you can see we're just writing that, okay, this is some simple arithmetic that we want to do. And when I say 8 plus 5, it then comes back and gives me the answer 13, okay? And then if you can see here, there's also, it follows your mathematical principles of operator precedence. So for example, if we gave it a command 2 plus 3 times 5, you can see that it gives you the answer 17 over there. And you could do things like exponentiation, so 3 to the power 2, which gives you the result 9 over there. You could do square root, so for example, square root of 10, and that's the result there, 3.16. Let me just make my pointer maybe more visible. Yeah, so hopefully you're able to see my pointer as well, and you can see some of these. There are also
The recording has stopped.
There are also some constants that are predefined.
This meeting is being recorded.
If you wanted to see the value of pi, those are what we call some reserved keywords, which are recognized. And so if you wanted, for example, the circumference of the Earth at the equator, you could say 2 times pi times 6378, and it'll give you what the circumference is over here. So that's just a sort of simple introduction to what how the interactive mode looks like. And what our command line will look like is something like this. So if, hold on, let me just move this. So here you're able to see what the R command line looks like. And we're just going to pass it some simple comments. So for example, here, it's very simple, 1 plus 1, 2. So you can see now it's saying I'm ready for the next command when you see the greater than sign. And then you can see here, if I put a hash 1 plus 1, it just ignores whatever comes after the hash. So it doesn't return you any output after that. But if I say 1 plus 1 and then put a hash, so remember everything after the hash is ignored, and then it gives you the value again of 2. It has other functions, like for example, if I said, give me everything from 100 to 130, it gives you the sequence of numbers basically from 100 to 130 in what we call a vector over here. So you can see that you can also have functions. So for example, a function called seek, which does the same thing over here. So one of the things you'll notice with R is that you can do things in the same thing in many ways. Here you can see I just said 5 minus, and what R did there was it told you that I'm expecting some more input. I can't just understand the value 5 minus, so I'm expecting more input, so it puts a plus command, which means your command is incomplete, okay? And then after it put that plus, we entered the value 1, and then it gave you 5 minus 1 is 4. Okay, so these are just examples of how to run things in the console directly in R. You can see here, this is the console, and we're running that directly in R. So you can use R as a calculator here. As you can see here on the console, you could do, for example, some multiplication. Here you're doing 2 times 3 is 6, 4 minus 1, we're just doing some simple maths. 6 divided by, into brackets 4 minus 1, which gives 6 divided by 3. It gives you 2, 9 to the power 2, 81. So it's able to do all that. Square root of 81, it gives you back the result 9. So whatever it gives you back here is actually the result, okay? You see 3, and then we said percentage 5. So it didn't recognize that And so what it then does is that it gives you that as an error to say, I did not understand the input where you said 3 and then %5. And you'll find out in a bit what that percent symbol is, or 2 percentage symbols in R, what they mean. So we call that the syntax. So, R has got specific syntax which you need to learn, and part of that is allows you to write scripts. So basically, in R Studio, you can generate a script. You basically say you want to generate a new file. It's like opening a new Word document, creating an R script, and then you can start to run a line of R code. Okay, from a script, you can highlight it, and you can click and run it, or simply put your cursor on it and press Control Enter. And so if I was to show you what an R script would look like here, so you see you can come to File, R script, and so now it opens a script window here, and then the console comes at the bottom. So this is using R Studio. And then in the script window, you can start writing your code, okay? You can write all the different commands that you wanted to, but when you highlight and run it, that's when it transfers it to the R engine, which is your console over here, and you can see, you can highlight and run that. So when you're running things sequentially, you may want to first just generate your script and then go step by step and see how that's running in the console. And is it the answers that you are expecting? Obviously, these are very simple examples. Well, as we get into more complicated, you'll be able to see how that can help. So in R, there are two things that we need to be familiar with. One is the concept of objects. So these are things that R will store, and also operations. So just getting into that, if you want to store anything in R, we need to create it as an R object, okay? And so if you were to see that here, you can see where we have this A, and then what we're doing by putting this greater than and a dash sign, so this arrow, left pointing arrow, we are assigning the value of 1 to this object called A, okay? So now if I wanted to reuse A, I can say A plus 2, so that's 1 plus 2, and it gives me a value of 3, okay? If I would say, for example, a command like print A, then it would print not the letter A, but it would print the value of it, which is 1. And you see here on the right side, you're able to see the object and what the value of it is over here. So you're able to see, for example, that we have an object called A, and it has a value assigned for it of 1. So the operator we use is this thing here, the less than sign, and then a dash. So the left, it creates like an arrow, a left pointing arrow, and you can see different commands here. So this is the assignment operator, the first one here, where we said A less than dash 1. So that's the left arrow 1. That means assign A the value of 1. Then I wanted to do some calculation. A plus 2, it gave you a value of 3. Print A means print the value of A. It gives you 1. If I put A as well, directly on the command, it'll give me, again, the value of 1. And ls means list. So if I wanted to see all the objects that are in the memory, which is basically, you can also see it from here, it prints that I'm holding an object called A in my memory as the R program. Okay, so that's how you store data in R. Just some simple notes about objects, object names. So like we had the name A, you cannot start it with a number. So you can't say assign 1 to 1, like something like that, because obviously it can't differentiate between. So object names cannot start with a number, and it cannot use some special symbols. So these are reserved for mathematical operations, the symbols that you see here. You could use a dot, and you could use an underscore in the object name. And one very important thing is that R is also case sensitive, okay? So if you had an object called num, for example, with capital M, that would be with capital N, that would be a different object from, num in small letters and num all in all caps, okay? So all these would be three different objects if you were to store it. So it's very important to know that R is case sensitive, okay? R will also overwrite any previous information stored in an object without asking you for permission, okay? So depending on what script you're writing, this is something you need to be careful about. But remember that it won't overwrite your data unless you're obviously writing it out, but it'll overwrite the object itself that's stored, okay? You can also view all the objects using the ls function, which I already mentioned. So here's an object example. We're going to create an example, just a very simple one of something called tossing a coin. So you can see here we're creating an object coin and we're assigning it the value of 1 or 2. So now when I say coin, you can see it's a vector of 1 and 2. But now if I misspell it with a capital C, R tells you I can't find that particular object that you're looking for called coin with a capital C. So that's just to show you that this is case sensitive over here. So we have a lot of basic operations you can do. So you could do, for example, these are the different symbols you can use. For addition, you would use a plus. Subtraction, you would use a dash, which is a minus. Multiplication, you use the asterisk or a star. You can see division is a forward slash over here. Exponential, you can use this character, it's called the caret, or a double star. So you can see x star star y would mean exponential. Here, to create a remainder, you can say x percentage y. And if you were doing some kind of matrix and you would want some inner products, you could do x percentage star percentage y, something like that. Okay, so just going back to your coin toss object here, let's create a coin. We already had that stored. You can see that here. So if we say coin -1, what it's going to do is every element in that list, it's going to go and subtract 1 from it. So if you had 1 and 2, it'll become 0 and 1, okay? If you do coin divide by 2, it divides everything by 2. So you can see it becomes 0.5 and 1. And then coin by coin, obviously that means you want to multiply, 1 by 1 and 2 by 2. So that becomes 1 and 4. And then coin plus coin, that means you add 1 and 1 and 2 and 2. So you get 2 and 4. And then coin, as we said here, with multiplying the matrix. So you're doing, 1 and 2, and then multiplied by 1 and 2 and in a vertical way. And then you get a product of 5 over there. So that's basically doing 1 times 1, which is 1, and 2 times 2, which is 2, and then adding those two to give you the answer 5 over there. So I hope that kind of, gives you a sort of small idea on how our commands are working. There are also logical operations. So we looked at these were mathematical ones, but they're also logical. So you can now say, for example, greater than, which is the, forward pointing arrow, less than. You can say greater than or equal to. So greater than equal to, less than equal to, equal to. So here you would use a double equals, okay? Not equal to, so not is generally this exclamation mark. And then you have an and operator, which is your ampersand, and an or operator, which is what we call this pipe, okay? So those are logical operations you can use. One of the important functions in R is this C function, and C is used to what we call concatenate or to combine. And what it does, it returns an expression or a vector with an appropriate mode, okay? And we'll see an example just now shortly. And then there's also this percentage operator which allows you to use or to keep or exclude values based on other possible values, okay? And just to show you an example of that, you can see here in you can see here an example. So what we're creating a new object called X, and that X, we wanted to have the sequence of 1 to 9, but by a step value of 2, okay? So you can see there, it gives you 1, 3, 5, 7, 9, all your odd numbers. And then we can say, show me a value of X, which is less than 4. So remember, it stored this in X, okay? So when we say X is less than 4, it goes and evaluates each one of these values. Is 1 less than 4? Yes, true. Is 3 less than 4? True. And then 5, 7, 9 are not less than 4, so it gives you false, false, false. Okay? And similarly, you can see the other one. So X equals 3 means it picks out just the value where the second value, so the rest are false, and the second is true. X is not equal to 3. So you can imagine that you can, as you're writing scripts, these become very useful in when you want to subset data or when you want to filter data, large data sets for the kind of values for which you're looking for. For example, give me all the data in Ethiopia for legumes, and those legumes should be, chickpea, groundnuts, whatever. And you can start filtering that for production or for population or for a particular parameter that you're looking at. So here it just gives you different examples, of all those different logical operators, whatever they mean. You can see and try and evaluate these. So I want to say X is greater than 3 or X is equals to 1, right? So here, the first one meets this criteria, and then you can see where it's 3, that will be false, and the rest, because they meet this criteria here, are then true, okay? So you can work out those different logical operators as we run it through this. Here you can see we said X is equals to 6, 7, 8, 9. So what it does, it gives you the output over there, okay? And it's telling you that in X that it's the object itself is longer, okay? So what it's done is concatenated. So remember we looked at this concatenate function. So here we're saying is X in these values of either 6, 7, 8, or 9. And you can see the 7 and 9 are there, so the last two are true. So this takes a bit of getting sort of used to how these logical operator works, but that's part of your, starting in programming, basically, in R. So in R, then, the way we run things is we have functions. You've got a sneak preview of the function called C, which was concatenate, or seek, which was the sequence function. But R comes with many functions that you can do sophisticated tasks, okay? For example, you could use a function called R. So here we are saying round off 3.1, the value of 3.14. So the data that you pass into the functions is called the function's argument. So the argument here is 3.14, and that's basically, you'll see what the value is. So the functions are always depicted by, the name of the function, which is R, in this case, round, and then these brackets, okay? So that will, in R, tells you that I want to run a particular function. So here are just some examples of functions that you can run. So let's look at, for example, that same function round and then a value of 3.14. We can look at a function of like factorial of 6. So, 1 times 2 times 3 times 4 times 5 times 6. It gives you a value of 720. What's the mean of these two of the sequence 1 to 2? mean of coin. Remember, coin was already there. You can see it over here. Round the mean of coin. So you can start combining functions as well. So remember, we said the function is the name over here with these brackets. And then whatever is inside the brackets are basically the arguments that you pass to that, okay, to that particular function. So a function always expects some kind of input arguments or some additional arguments or parameters that you need to provide. So for here, we're now going to look at some R function arguments. So you can give R, for example, sample values of X ranging from 1 to 4, and let sample for me 2 values, okay? So it gives you, over here, it randomly samples it and gives you the value of 3 and the value of 2. If I was to run that again, it'll give me some other random values. You can see here, sample X coin, where the size is 2, then it gives you a value of 1 and 2. And likewise, you can see. So here you're combining functions, for example, one called sample, and then you can give another one. And the order of the arguments, if they're specified, should then not matter. So you can see here, and the beauty in RStudio is when you're typing in the function, it also gives you what the parameters it expects are. And anytime you want to get some help on any function, you can just type the command question mark followed by the name of the function. So if I said question mark sample, you can see in Q4, the quadrant 4 here, it gives you what is the description about that function, but also what are the expected arguments that you want for that particular. So you can see over here, what are the usage arguments? It expects something, an object called X, in which case, in our case, that was, for example, the coin object, and then what is the size that you want of that particular random sample, okay? So these are just introductions to how functions work. In R, you can also store data in different types. I'll just run over this quickly. So you could store it as a numeric, which is basically a number. So if I gave X the value of 1 without any quotes, so these quotes, that means it stores it as a numeric character. So X will then have the value of 1 as a number. Here you can see X as a character. So here it'll basically, X will be assigned a value called alien. And that alien is basically a string of characters. So we call this a character string, and you would have the word ALIEN stored in the value of X. You could have logical data types as well. So here you can give the value X the value of true, or you can give it the value of false. And you could have factors as well, which you will see shortly. So factors are basically categorical data types where you have levels, okay? So for example, you might have a factor called levels over here, and then these are usually human readable levels. So for example, in this case, 0, the value of 0 or the factor 0 is assigned to humans, and the value of 1 is assigned to aliens, okay? And factors are very useful when performing statistical analysis because you can use numeric coding with value labels. So for example, here we assign the value of 0 to humans and the value of 1 to aliens, okay? You can also, R is very powerful with what we call vectors. And in R, a vector is basically a one-dimensional object that can have anywhere from 0 to a very, very large number of elements, okay? And then R does not distinguish between vectors and scalars. To create a vector in R, you use that concatenate function. Remember, we saw the C and then open and close brackets. That's what you would use to create a vector in R. And then, as we mentioned, the character vectors, each element is contained within quotation marks. So if you put quotation marks um, um, then it'll be a character, so it'll basically be the word true and false. But if you don't put quotation marks, then it'll be the actual logical vector true and false. So those are just things you need to, as you go along, you'll be learning about. So here we just go through an example. You're able to see here, we have the coin object, which has, remember, 1 and 2. If I say, what's the class of it? It's an integer. So it tells you that 1 and 2 are actually integers stored in this particular vector, okay? If I say the X object, remember we had stored an X, is now giving you, if I say the class of X, it's telling me that that's a logical vector. If I say Y, so if you were to get the value of Y, because they are mixed, you can see you have 1, 2, 3 as in quotation marks, and then 4. So those are all classified as characters. And if I had a factor called alien, then it would tell me that this factor has, it's a factor that is stored in there. The object is called alien, but it has 2 levels. Either it's human or alien. So, you know, the first was a human, the second an alien, the third an alien, and then after that, 2 humans. Okay. So that's a little bit about vectors. So something you need to be aware about is that in R, when you're dealing with different types, R tends to coerce it into one single type. So that within one object, there can only be one type of data. So if you mix, for example, numbers and characters, then your entire object will become a character object. So you can see here, for example, if I mix numeric, so here I'm giving true the value of 1 and false the value of 0, then I can convert that to a numeric vector. But if I convert it, if I put the quotation marks, then I can convert it to a character vector, okay? And numbers can also be cursed into characters. So if I said, for example, character 5.6, and then I put the quotation marks, it then makes it. So this becomes very important because remember, as you read in data from different sources, there are people designate missing values in different ways. Either you could have a dot or a blank, or some people put NA, some people put NA as a character. Some, depending on what data it is, you may designate a value of minus 99. So this becomes very, very important, especially for, you know, when you're importing data and you want to see how missing values are coded, okay? So these are just some examples I wanted to give. You know, if I was there, this would be a more interactive exercise. I wanted to ask you the questions, what do you think will happen to these particular vectors? If I said combine a numeric and 2 logical vectors, what do you think will happen? Here I'm combining a character and a logical vector. Here a numeric and a character. And then number 4, I'm combining a character, logical, and, a numeric, logical, and a character data type. So what would happen? You can run this and see the answers for that, okay? So you can see here when I say character, so it converts everything to numeric. Here it converts everything to character. Here it converts again everything to character. And the same in the 4th instance as well. It converts everything to a character. So that's what we mean by data coercion. Okay, and you need to be aware about this when you're using R, especially vectors in R. We can also have matrices in R. It's very similar to vectors, but in this case, it has 2 or more dimensions where you have rows and columns in these matrices. So like vectors, matrices can contain only one data type, and then you can construct it with this command called matrix. So here you see we're generating a matrix, 1 to 6, matrix assigned to an object M. and we're saying it should have 2 rows and 3 columns. So you can see here the 2 rows, 1 and 2, and then the 3 columns, 1, 2, 3. And so it starts from column 1, basically it says 1, 2, 3, 4, 5, 6, like that, okay? And if I wanted to get a particular element of that matrix, so here I'm saying give me the element 1, 3, so I would go, remember, row 1, column 3, it gives me the value of 5 that you expect over there. So that's just matrices. There's also data frames. This is what makes R very powerful, okay? It's because it's very similar in nature to what you would use, for example, in Excel, like a spreadsheet of data. So for example, you had some ages, which are numeric characters, and then you had some other data. In this case, what is that individual and which hand do they use? Are they left-handed? Are they right-handed or ambidextrous? So you have some categorical data over there. So that's how you would store it in a data frame, okay? And you can see different functions there that allow you to basically say what are the dimensions. So when you're dealing with very large data sets, this becomes very important because you want to see how many rows do I have, how many columns do I have, what are the first 10, what are the last 10. You can use this to slice and dice data. You can subset data. So for example, here we have the value of X. And if I said X and then in square brackets, so remember when you use square brackets, that basically tells you I want a specific element of that vector. So in X and then square brackets 4 is telling you I want the 4th element. So if I count here 1, 2, 3, 4, so it gives me the value of 7. X is greater than 2. Remember, we saw that. So is 1 greater than 2? No, but then everything else is. So you have false and then trues. And then you could do something like give me all values of X where X is greater than 2. Okay? So then it gives you the values of 3, 5, 7, and 9. So here you've kind of subset that data already, the vector. You could subset matrices in the same way. In this case, you would have 2 dimensions. So you see here, you're saying, give me a subset of the first 2 rows and the first column, right? So give me, it's always rows and then columns. So give me a subset of that, okay? So here you can see then it subsets it to 1, 3. If I said the first first row and 2 columns, it gives me the value of 1, 3. And you can do all kinds of different analysis there. You can also subset data frames. So here you can see, for example, I wanted to subset this data frame, first 2 rows and the first column. So it gives me value of 25 and 30. Gives me, again, first 2 rows and the column age. So it gives me the same. So I could specify either the element number or I could specify the column as well. Okay. And then the other way of specifying the column is this dollar sign. You'll see often there's a dollar. So this is telling you go to the data frame DF, look at the column age and give me the second element in that particular column. So that's just giving you how you can use that. And then the other example here is telling you subset for me the whole data frame where age is greater than 30. So it'll give you row 3 and row 4 where it meets the criteria of age greater than 30. Okay, so those are all the different syntaxes you should be used to. Quickly, I just want to go through different libraries and packages. I know this has become a long session. Sorry about that. You haven't had your break yet. But I want to cover this because it's very important. And this is where the power really of R lies. Okay, so libraries and packages, R comes with a set of base R functions. So if you want to think of this in relation to for example, your cell phone, when you first buy your cell phone, it just comes with the Android operating system, right? So you could think of that as R base R is the Android operating system. It has some basic functionalities. It has a calendar, it has a phone, it has a messaging app. It has, features about the battery, a control panel, things like that. But when you then want to do additional things, you start installing apps, right? So you will install, for example, Gmail or WhatsApp or your banking app, something like that. So if you want to think about it, those apps are like libraries and packages. The apps in your cell phones are like libraries and packages. So if I install, for example, WhatsApp, it allows me to do instant messaging. If I install my bank app, it allows me to transfer money to someone else. So, I would say, for example, open my bank app and then say, transfer 100 birr to Ermias or something like that, right? And that's basically like a function that you're asking it to do. So R comes with the base R functions, which is like the operating system itself or the engine itself. And then you can install libraries, okay, and packages, which are like a collection of functions. And depending on what you want to do, there, as I mentioned, there are very, very many libraries out there, okay? And the way to install is you say this command, install packages. So for example, if I gave it a command install.packages, and then remember that's the command itself, so the function itself. And then in the quotes, you would say which package. So dplyr in this case is one of the highly used packages for data wrangling. It's dplyr, like a data, using pliers, like a toolkit on data. You can install packages like that, okay? And you'll see. In genomics, bioinformatics, we use a package called bioconductor. So over there, you can see it comes with its own installation. For example, you can say BioC Manager install. It comes with its own function to install. And then you can say install for me a package called BioBase, for example. Okay. I know I'm rushing through this. You'll be able to see this in more detail. The thing is, same as your phone, you will only need to install an app or an R package. You need to install it only once. But when you want to use it, you will need to load it, okay? So it's like saying, yes, the app is on my phone, but when I want to use it, I need to click on it. I need to activate it. And to activate that app, you use a command called library, okay? So library dplyr will basically say, okay, now I want to use the app or the package dplyr over here, okay? So these are very common packages that you use for data management, for data wrangling, for very large data sets, called dplyr. ggplot allows you to do very beautiful visualization. So it's mainly used for, it's a library used for plotting, which you will hear about later on. And then tidyverse, which allows you to basically the umbrella package that allows you to do all the data management, data wrangling, so different functions that come with that. There is an additional data type that we call tibble. It's very similar to a data frame, but it allows to give you more information. I will go through that. The tidyverse function also has this pipe operator, so the percentage greater than percentage sign, which allows you to basically nest different functions. So, if you get output from one function, you can funnel it into the next function over here there using the pipe function. So for example, if we had an object called x, which had these values, I could get the mean of it, I could get the square root of it. But you see here, I'm doing things one by one. So here first I gave it the command for x, and then I said mean. But if I wanted it to run x and then run mean on that, I would just say take x and then pipe it into mean, and it gives me directly that. So I could say x take X, give me the mean, and then give me the square root of that. So if I wanted to do all of that in one line, I could just pipe the output from X into as the input into mean, and then the output of mean into the input as input for square root, and then it gives me directly the number. So here you're doing things separately. Here you're doing everything in one single line using what we call this pipe operator. Okay. I just wanted to quickly mention about R Shiny. So one of the very powerful things about R is that once you've developed your scripts, once you have your data sets, you can make these easily available as a web application using this package called R Shiny. And that's something we've done as developers. We use a lot to provide our packages and functions to end users who are not familiar with R, okay? And this can use interactive apps coming from also R and Python as well. So I just wanted to mention that. I've put down a list of different resources for those of you just beginning. There's lots of online resources available for, introduction to R, R for data science, different cheat sheets. So these will give you all the different syntax that I kind of mentioned and a lot more. There are also training programs that you can do. And then these are the two different references in terms of if you wanted to buy some books or online resources. These are very good references to start with. Just to mention that we do conduct courses which are longer, so not just for one day. In Nairobi at IITA, we actually have a course in March, if any of you are interested. This is mainly on bioconductor, which is more a package for genomics and transcriptome. So if any of you are working in that area and you would like, feel free to visit the website and at least register for updates about the courses. We do make most of our course material available online through Moodle and different different platforms for open access to our training material. So thank you all very much. I hope that gives you an introduction to R. I just wanted to quickly, if I have 2 minutes, take you through, if you're able to see my screen. I'm not sure. Sorry, let me stop sharing. I just want to share my other desktop here and show you two quick things. I know we have a, oops. Are you able to see my screen? Huh?
Hello.
Hello.
I think you finished.
Yes, there's some things I wanted to show. Let me just show you some quick examples of, I know there's a wide audience on this call. So I just wanted to take you through one very nice starting point is if you go to the CRAN-R website, I hope you're able to see my screen, which is showing that you should be able to go to, on the left, there's this thing called task views. And if I go to that, it gives you all the different kind of topics and the different packages which are useful. So for example, I know some of you come from spatial analysis. So whether that's geospatial, whatever, you can click on spatial and then it gives you all the different packages that are available in the repository regarding different spatial data. So for example, if you wanted raster data, geographic metadata, you could go and look at all these different packages that may be of interest in that particular field of research that you're involved in. So that's something that's very important, and I thought it's good to point out as a good starting point. So you go to the CRAN